ChatGPT, Claude, Gemini, we're literally all using these tools every single day, right? You type a prompt, you hit send, and boom, you wait for the magic to happen. But have you ever actually stopped to wonder what is really going on under the hood in those few seconds? Seriously, almost nobody truly understands the hidden mechanics of what happens right after they hit send. Well, today, we're going to change that completely.
Welcome to this explainer on demystifying large language models, or LLMs. We're going to break down how AI actually works. And honestly, the best part, I promise you won't need a computer science degree for this, and we're skipping all the complicated math. The core mechanics of these incredibly powerful systems are actually surprisingly intuitive once you break them down properly. By the end of this, you are going to see AI in a completely different light.
Okay, so let's dive right in. Here's our roadmap for peeling back the layers of the AI onion today. First, we'll look at tokens, the AI's currency. Second, next token prediction. Third, we'll draw a hard line between training and inference. Fourth, understanding parameters. And finally, exactly why AI hallucinates.
Section 1. Tokens, the AI's currency. These are the fundamental building blocks of AI language.
So when you type a prompt into ChatGPT, you're obviously thinking in words. But here's the kicker. The model doesn't actually see words at all. The very first thing that happens to your text is that it gets chopped up into pieces. Take a word like unbelievable. To us, that's just one single word. But to the AI, it gets broken down into 3 distinct tokens: un, believe, and able. Now, a simpler word like cat just remains 1 token, cat. But cat's plural. That suddenly becomes 2 tokens, cat and s. Even numbers become tokens. What's kind of wild is how this scales. A simple word like apple is 1 token, but a really complex, dense math equation might get shattered into dozens of individual characters and symbols. And this isn't just some weird quirk, right? Breaking text into these little pieces gives the model massive flexibility. It basically keeps the model's vocabulary size manageable and lets it handle totally unfamiliar languages and endless word combinations incredibly efficiently.
But why does knowing this actually matter to you? Well, it matters because every single LLM out there has a finite working memory. And that memory is measured in tokens, not words. To put that into perspective, GPT-4 has a limit of roughly 128,000 tokens in one single conversation. You can kind of think of tokens as the actual currency of the model. Every word you type costs tokens. Every response the model generates, that costs tokens too. So when you hit that 128,000 limit, the model physically runs out of room in its working memory and just starts forgetting the earlier parts of your conversation. It's not being difficult, it's not ignoring you, it's simply out of brain space.
So you've hit send, and your prompt has instantly been converted into this currency of tokens. What happens next? How does the AI actually generate its reply?
That brings us to Section 2. Next token prediction, the deceptively simple core mechanic.
The extraordinarily sophisticated engine of an LLM actually boils down to one surprisingly basic, frankly, embarrassingly simple task. It just predicts the next token. Literally, that is it. Given all the tokens it's read so far, it calculates what token is statistically most likely to come next. So if the tokens so far are, the capital of France is, what comes next? Paris. I mean, it's obvious to us and it's obvious to the model because it has seen that specific sequence of text millions and millions of times. It just picks the most statistically likely continuation. Here is how that step-by-step process happens in real time. First, the model reads all the tokens you provided. Second, it predicts the highest probability next token. Third, it adds that single token to the sequence, and then it just repeats the process to predict the next one, and the next one. That whole stream of text you see magically appearing on your screen, kind of like a super fast typist, that is literally just the model predicting and adding one single token at a time in real time. I really want to emphasize a stark contrast here. The model is not thinking. It's not reasoning the way a human being does. What it is doing is extraordinarily sophisticated pattern completion. The only reason the AI seems so highly intelligent is because human language naturally encodes intelligence. When the model learns to flawlessly predict human words, it naturally learns to predict thoughtful, intelligent-sounding things. But at its very core, it is just pattern prediction.
Which naturally leads us to a pretty massive question. If it's just completing statistical patterns, where on earth does the AI learn which tokens are mathematically likely to follow others in the first place?
To answer that, we look at Section 3, Training versus Inference, 2 completely separate phases of AI.
Drawing a hard line between these 2 phases clears up a ton of misconceptions. The training phase is when the model actually does its learning. It basically reads an enormous portion of the internet. We're talking books, research papers, code, the whole shebang. Every time it predicts the next token wrong during this phase, it adjusts itself slightly. And it does this billions of times over weeks or even months. It costs literal millions of dollars. But once that's done, the model is completely frozen. Then we enter the inference phase. Inference is what happens when you actually use ChatGPT. You're using a frozen model. The public AI you're chatting with does not get smarter from your individual chats. When you close the tab, it has zero memory of what you just discussed. It's simply applying its frozen training to respond to your immediate prompt.
Now when discussing these massive training phases, you'll often hear industry jargon tossed around. People will casually say, oh, this is a 70 billion parameter model or a trillion parameter model. But what does that actually mean? Where is all this learned information physically stored?
That takes us to Section 4, Understanding Parameters, the AI's encoded memory.
Parameters are the physical storage mechanism for everything the model absorbed during that super expensive training phase. Think of parameters kind of like this. Over your lifetime, your brain builds subconscious patterns to recognize human faces, right? You learn the spacing of eyes, the general shape of noses. You can't consciously articulate the exact math of a face, but those patterns are deeply encoded in your neural connections. Well, parameters are basically the AI equivalent of that. They are numerical values encoded deeply in a neural network that represent absolutely everything the model has subconsciously learned about language patterns and reasoning.
So, to quickly summarize parameters, they represent the memory of the training data. They are entirely frozen during the inference phase when you're actually using the tool. They do the heavy lifting of turning your token inputs into text outputs. And crucially, the more parameters a model has, say a 70 billion parameter model versus a 7 billion one, the more nuanced the patterns it can recognize. However, keep in mind those larger models require significantly more computing power to actually run.
Okay, so if we have these massive models, loaded with billions of parameters of encoded knowledge, doing all this extraordinarily sophisticated token prediction, we inevitably arrive at the most frustrating question of all. Why do these incredibly smart systems sometimes confidently state completely wrong things?
Which brings us to Section 5, Why AI Hallucinates, the Flaw of Confident Nonsense. Understanding this flaw is honestly the major payoff of understanding how these machines actually work. Hallucinations are not just some weird bug that engineers are eventually going to fix. They are a fundamental, unavoidable property of how next token prediction operates. A hallucination occurs when the AI predicts an answer that sounds entirely plausible and is totally statistically likely based on language patterns, but is completely factually wrong in reality. Remember, the model doesn't have an internal human sense of uncertainty. If you ask it a highly niche question or something that happened after it was trained, it doesn't know that it doesn't know. It just blindly tries to complete the pattern.
So the crucial takeaway here, and if you remember one thing today, make it this, is that the model is not looking up facts. It does not have some magical internal database it's searching. It generates confident text because confident text is incredibly common in its training data. It writes an answer that looks correct even when it's totally wrong because it literally cannot know it is wrong. This is exactly why your human judgment and your ability to verify facts is completely irreplaceable. When you actually understand these mechanics, you realize this isn't just some academic theory. It literally dictates how you should use the tool every single day. Because it forgets past sessions, you must always provide complete context in your prompts. Because it has a token limit, you need to be really strategic when uploading long documents, so you don't exhaust its working memory. Because it just predicts instead of actually thinking, you have to give it highly specific constraints. And because it doesn't search live databases, you must always verify the facts it gives you.
Understanding the machine makes you dramatically better at operating it. If you found this breakdown helpful and you really want to build real, practical skills in AI, you should absolutely check out the Sahil AI Academy on YouTube for daily content that breaks down concepts just like this. And if you're serious about becoming a true solution AI engineer who actually builds with these systems, you can join Trinity Corp's Academy.
We've covered a ton of ground today, right? From tokens and parameters to the big difference between training and inference and the true cause of AI hallucinations. So I want to leave you with this final thought to consider. Now that you know the AI isn't actually thinking but is just rapidly predicting statistical tokens, how will you change the way you write your very next prompt tomorrow? Keep that in mind, and I'll catch you in the next explainer.